Okay, this video will be just an overview of when you can and can't use substitution immediately, mostly on when you can't use substitution immediately. So I'll review just very briefly, what the last video said. When you always can use substitution is when you have a polynomial or a radical. There's a little bit of a limitation there, but you'll know that ahead of time. So substitution can always be used here. And then when substitution can't always be used right away is when you have rational functions. Anything that's 1 over x or maybe x over x, and there's more to that. But you can't just always use substitution. So let's get to when you can and when you can't. So here's an example of a rational function. All right. Clearly, if x is equal to 4, the denominator would be 0, and then there would be an asymptote. But look at what it says you have to look at. You have to look at the limit as x approaches 0. Well, if we plug 0 into both of those, you're going to have -5 over -4, which is just positive 5/4. So if you've got a rational function, but what x is approaching does not cause the denominator to be 0, then you can use substitution. So let's look at the times when you can't use substitution. So now we have a limit where x is equal, cover this stuff up, where x is equal to 2. We've got a rational function. And notice that in the denominator, if we put 2 in here, that causes the denominator to be 0. So remember, a second ago, I mentioned that what you're going to want to try to do first is factor. Well, x squared subtract 6x plus 8 factors to x subtract 4, x subtract 2. Yes, in calculus, you use a lot of algebra 1. Well, those cancel now. So now you would then write the limit as x approaches 2, x subtract 4, and now you can substitute 2 subtract 4 is -4. And you might also want to put where x cannot equal 2, just to let your professor know, hey, I know that's a rational function. I know there'll be an asymptote at 2. That's just a good idea to do. All right, the next, cover this up. It's another example. So where the limit as x approaches 1, and you've got this function. Well, notice in the numerator you have a difference of squares. So that factors to x plus 1, x minus 1. And now, because these are factors here, it's multiplication, you can cancel, and now you can substitute. 1 plus 1 is 2. Hope you guys are getting the hang of it. Let's do another one. So now the limit as x approaches 0, you have this polynomial. But it's just over x. So it doesn't matter. This is going to be, as x approaches 0, this is going to be a does not exist, because x doesn't cancel with anything in the numerator. You can't get rid of this. So when you substitute this, at least for right now, this is what I want you to understand, that this right here will not exist. There will be no factoring that will help, because this will factor. That'll factor to x minus 1 squared. Oh, that's supposed to be a plus 1 right there. X minus 1 squared, but that is still over x. So it doesn't matter what we do in the numerator. There's nothing that'll cancel out the denominator, so we're stuck with does not exist. Hopefully I provided enough examples for you to understand that substitution can work with rationals if you do appropriate factoring. And once in a while, it'll work if you're paying attention to this piece right here. If you're paying attention to the, oops, red's not a good color for that. if you're paying attention to what the x is approaching and notice that it does not cause the denominator to be 0, then substitution will work. All right, that's it for this.